Imagine this. You're an intrepid explorer, somehow suited up in an indestructible spacesuit that lets you survive the impossible just long enough to experience the horror. Today, we're diving literally into 5 Serpentis A fascinating F8 IV subgiant star located about 82 light-years away in the constellation Serpens. This isn't your average star like our Sun. It's a bit older, bigger, and hotter, on its way to becoming a red giant. But what if you fell into it? Spoiler, it wouldn't end well. Let's break it down, step by terrifying step. First, a quick profile on our stellar victim, destination. 5 Serpentis A has a spectral type of F84, meaning it is a subgiant, with a surface temperature of around 6025 Kelvin, that's about 4% hotter than the Sun's 5772 K. It packs 1.16 times the mass of the Sun into a body that's roughly 2.1 times wider, giving it a radius of about 1.46 million kilometers. Its luminosity, a blazing 5 times that of the Sun, shining with the energy of 5 suns combined. At 5.7 billion years old, it's middle-aged in star terms, with a contracting helium core that's causing it to swell up like a balloon. Oh, and it's part of a binary system with a cooler K for orange companion star orbiting at a safe distance, but that's not where we re-headed today. Phase 1. The long fall in. Let's say you start your doom journey from a safe distance about 1 astronomical unit away, similar to Earth's orbit around the Sun. Adjusted for this star's brightness, the heat here would already be intense. As you plummet inward, the star grows from a pinpoint to a looming orb. Tidal forces start to tug at you, your feet pulled harder toward the star than your head. For a star this size, though, it's not like a black hole. The differential gravity is survivable at first, maybe just a queasy stretch, but radiation, that's the real killer. Ultraviolet and X-rays bombard you, stripping electrons from your atoms. Even in your magic suit, your DNA would be fried in minutes. Fun fact, surface gravity on 5 Serpentis A is lower than the Sun's, about 72 meters per second squared compared to our Sun's 274 meters per second squared, thanks to its larger size, despite the extra mass. But as you accelerate, your speed hits thousands of kilometers per second. Escape velocity from the surface is around 400 kilometers per second, less than the Sun's 618 kilometers per second, but you're not escaping. You're diving in. Phase 2. Skimming the corona. Now you're closing in on the star's outer layers. First up, the corona, a superheated halo extending millions of kilometers out. Temperatures here spike to over 1,000,000 Kelvin hotter than the surface, thanks to magnetic weirdness. Solar wind equivalents blast past at supersonic speeds, carrying charged particles that would sandblast your suit to nothing. If you somehow survive, the chromosphere awaits a thin, turbulent layer where temperatures drop to just 20,000 K. Here, you'd see massive solar flares and prominences arcing like fiery bridges, each one larger than Earth. One wrong move, and you're vaporized by a coronal mass ejection equivalent to 1 billion hydrogen bombs. Remember, stars like 5 Serpentis A don't have a solid surface, it's all plasma, a soup of ionized gas. As a subgiant, its outer envelope is puffier than the Sun's, with stronger convection currents churning like a boiling pot. Phase 3. Plunging through the photosphere. This is what we call the surface, the photosphere, where the star's light escapes. At 6025 K, it's a wall of searing plasma. Your body, instantaneously incinerated, atoms dissociate. You're now part of the star's atmosphere. But let's pretend your consciousness lingers for the science. Density here is low like a thin gas, but pressure builds fast. You're falling at near escape velocity, slamming into hydrogen and helium ions. Friction turns you into a streak of plasma, like a meteor burning up. But on steroids. Phase 4, the convection zone descent. Deeper now, into the outer third of the star, the convection zone. Here, heat bubbles up in massive cells, each the size of planets. Temperatures climb to 2 million Kelvin, and density jumps to that of water. You're squeezed by pressures millions of times Earth's atmosphere. Fusion isn't happening yet, but the plasma is roiling, carrying you in turbulent currents. As a subgiant, this zone is more active, with the star's expansion making the ride even wilder. Think eternal hurricane in hell. Phase 5. The radiative zone ordeal. Halfway in, you hit the radiative zone, where energy creeps outward via photons bouncing like pinballs. Temperatures soar to 7 million Kelvin, density like solid lead. Photons take thousands of years to escape from here, but you're plummeting fast. Gravity compresses you further. Any remaining molecules are crushed into nuclear soup. Phase 6. Core catastrophe. The heart of the beast, the core, just 10% of the radius, but holding half the mass. Temperatures hit 15 million Kelvin, hot enough for hydrogen fusion into helium. As a subgiant, 5 Serpentis A's core is running low on hydrogen, building a helium ash layer that's inert and contracting, heating things up even more. Pressure at 200 billion atmospheres. Density, 150 times water's. You're not falling anymore, you're fused. Protons smash into your atoms at relativistic speeds, turning you into heavier elements in a blink. In essence, you become star stuff ... literally. And just like that, you're gone, assimilated into 5 Serpentis A, which barely notices your tiny mass addition. In reality, you'd never make it past the outer layers. Radiation and heat would end you light years out. But this thought experiment reminds us, stars are cosmic furnaces, forging the elements that make us. Next time you stargaze, remember falling in is a one-way trip to becoming part of the universe's grand cycle. Thanks for joining this stellar plunge. What if next? Let us know.